So we've been talking about exponents, and so this week 5, solving applications using those exponents. So it says the mass of Jupiter is about this large. Okay, that's a big mass, right? And the mass of the Sun is about this large. About how many times the mass of Jupiter is the mass of the Sun. So the idea is the mass of the Sun is larger than the mass of Jupiter, and we're supposed to figure out by how much, how many times. So the idea is you would use division. So for example, if I were to say a child, a 14-year-old boy, weighs 100 pounds, but an elephant weighs 800 pounds, how many times larger is the elephant than the boy? And you'd say, oh, well, the answer is 8. Okay, now the way you got the 8 is you probably used mental math. You said, well, 100 times 8 is 800. Done. But if you couldn't do that math in your head, the way you would do it is you would take that 800 and you would divide by 100, and you would say, oh, the answer is 8. Okay, so that's what we're going to do, because we know we've got Jupiter, and we know we've got the Sun, and we know that the Sun is larger than Jupiter. Whoa, geez. And we know that the Sun is larger than Jupiter. We want to figure out by how many times. And since you can't just do it in your head, like with the boy and the elephant's problem, you're going to use division. And we're going to take the Sun, just like we took the elephant, and we're going to divide by Jupiter, just like we divided by the boy. All right, so we're going to take the Sun and divide by Jupiter. All right, so what that means is I'm going to take the Sun, which is 1.998 times 10 to the 27th power, and we're going to divide by Jupiter, which is 1.900 times 10 to the 24th power. All right, so now we're going to divide these guys, right? So what is that going to look like? Well, what we learned with our exponents is we're going to leave these guys the same for right now. And so, yeah, let's do that. Shucks. Yeah, well, there's a couple of ways we could do this. So let's leave that for right now. So that's going to be 1.998 over 1.9, because we don't need all those extra zeros. And then we have this. All right, well, these 24 tens down here being multiplied, and these 27 tens being multiplied, we see that all these 24 tens are going to cancel out with 24 of the 27 tens. So all 24 tens are going to cancel out, leaving us with just 3 of the tens in the numerator being left over, right? So you end up with 1.998 times 10 to the third power over 1.9. Okay? Now, technically, that's the answer, but they want us to give an answer rounded to the nearest thousandths place. Wait, does it say thousands or thousandths? Rounded to the nearest thousandth. All right? So now, let's simplify this. So if we were going to simplify this, first off, we're going to use a calculator. And so the first thing we need to know is what the heck is 1.998 times 10 to the third power? Well, since this exponent is positive, that means we're going to multiply and make this number bigger by 3 place values. So that becomes 1998 over 1.9. There we go. And we're going to use a calculator again, and now we're going to just divide with a calculator, and I have no idea what that answer is off the top of my head, so I'm going to bust out my calculator, and I'm going to divide 1998 divided by 1.9, and I get this god-awful ugly number. I get 1051.57894 blah 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 But they said round to the nearest thousandths place. Tenths, hundredths, thousandths. So the 8 is the thousandths place. That's where we're supposed to round to. And this 9 says to round up. So our answer is 1051.579. And that is our answer. Now, I forgot to mention that we also, what they want us to do is they want us to write the answer, and I'm going to zoom in so you can see it. They want us to write the final answer in scientific notation, all right? So that's the key, scientific notation. So my answer is correct, but it's not in scientific notation. So what is scientific notation? Well, scientific notation means you need to take this number and you need to take that decimal point, and actually you need the decimal point to be in the front. All right, so we want the decimal to be right there. You only want one digit in the front. So then we know it's going to be times 10 to some power. So how do I take this decimal and put the decimal so that it's right here? Well, the decimal is here, and it's going to move over. It's going to get larger by 3 place values. So we know we need this 10 to be raised to the 3rd place value. But now we're going to rethink that thousandths place. We don't need this thousandths. We need to think about this thousandths. So that's 10 hundredths, tenths, hundredths, thousandths. So there is our thousandths. So this 5 tells you to round up. So really what we're going to do is we want to put in 1.052 times 10 to the 3rd power. Now this is the answer we want to put into our math lab, not this. Okay, now, but here's the key. When you enter in the answer, this multiplication symbol, you cannot just use the letter X. What you're going to do, you're going to zoom up, and I'm going to zoom in. When you enter in your answer to your My Math Lab, for that multiplication symbol, you need to use this multiplication symbol on your palette. So that's what they're talking about. So half the trick is learning how to enter in the answer properly. All right, so here we've got, it takes 2 times 10 to the 7th years, that's a big number, for a particular star to make one orbit around its galaxy. Assume that this star's orbit in its galaxy is circular with a diameter of 10 to the 4 light years. This is a lot of reading here. A light year is the distance that light travels in 1 year, and there are about 5.859 times 10 to the 12th miles in 1 light year. Estimate how many miles this star travels in 1 year. Oh my goodness. So it says it takes this many years for it to travel around to make one orbit around its galaxy. And we know that a light year is the distance that the light travels in 1 year, and there's this many miles in a light year. How many miles will the star travel in 1 year? So basically what we need to do is they've given us some extra information that we don't really care about. It says, oh wait, no, we do care. No, we don't care. It takes this many years to travel around, to make a big old circle, right? It takes that many years to make a big old circle. And then down here, it says, this is how many miles it travels each year. Each year it travels this many miles. So estimate how many miles this star will travel. That means we need to take this big old huge number and multiply by this big old huge number, and that's going to be our answer. Oh my gosh, that is huge. So this is going to be 10 times 2 times 10 to the 7th times 5.859 times 10 to the 12th. Oh my goodness. So using the commutative property, because basically all of these digits are being multiplied. This 2 times 10 to the 7th times 5.859 times 10 to the 12th. So really we have 1, 2, 3, 4 numbers all being multiplied by each other. And so, oh my goodness. So this, using the commutative property, we get 2 times 5.859 times 10 to the 7th times 10 to the 12th. All right. So I'm going to use a calculator to get this portion right here. So using a calculator to get just that portion. So that's going to be 2 times 5.859. That gives me 11.718 times, and then this portion right here, that's equal to 10 to the 19th power. How do I know that? Well, because if you think about it, 10 to the 7th means 10, 10, 10, 10, 10, 10, 10, 7 times, times another 10 to the 12th, which is 10, 10, 10, 10, 10, 12 times. So you've got 7 tens and another 12 tens all being multiplied, so that's 19 of them. So that's 11.718 times 10 to the 19th power. So you're done? Not quite. Because scientific notation means you're supposed to have only one digit in the front. So this portion right here is really equal to 1.1718 times 10 to the first power. That's this. Plus we still have, we're multiplying by 10 to the 19th power. So that means our real answer is 1.1718 times 10 to the 20th power. Now let's make sure, and it says round to 1 decimal place as needed. All right, so I'm going to go down here, and they want us to only round to 1 decimal place. So that 7 tells us we need to bump it up. So it's going to be 1.2 times 10 to the 20th power. Holy moly. You know, to be honest, the math was pretty straightforward. What, to me, the hardest part was recognizing what the heck we were supposed to do in the first place. And it took me quite a while to recognize, oh, they gave us extra information. They were just talking about a whole bunch of stuff. And really all we needed to do was understand that it's this many years, this far traveled each year, so we just need to multiply. And that's it. We just had to multiply. And it took me a while to figure that out. And once I understood, oh, I'm supposed to multiply, the rest was pretty straightforward. Yeah, it's a lot of steps, but it's pretty straightforward. And the tricky part was just reading for me, not the math. So don't get frustrated if, for you, the trouble is also the reading. So here it says a moon is about 540,000 miles from the planet it orbits. Write this number in scientific notation. And then if a rocket traveled at this many miles per hour, how long would it take for it to reach the moon from its planet? Okay, so 2 steps. So the first step, so first step is we're going to write this number in scientific notation. So remember, scientific notation means, let's move over here. So we've got 540,000. Scientific notation means we have to have that decimal in the front. All right? So, and it's going to be 5.4 times 10 to the something. So what do I need to multiply? What exponent do I need to have in order to turn this number into this number? Well, we know we're going to take this number and make it bigger because that's a big number. And because the decimal is right here between the 5 and the 4, and we need it to end up right here. So that means our decimal needs to travel 1, 2, 3, 4, 5 spaces. So we want a 5 right here. So 5.4 times 10 to the 5th. That is our scientific notation. 5.4 times 10 to the 5th power. By the way, you do need to use the multiplication symbol in the math palette, so make sure you use that. You can't just use the letter X. So now the idea is that's how far the moon is from the planet. And we know, so you've got your planet, you've got your moon, and we know that the distance between these two locations is 5.4 times 10 to the 5th power. And we know that a rocket is traveling, and it can travel at a certain speed, 9 times 10 to the 4th power, 9 times 10 to the 4th power. And we want to know, well, how long is it going to take this rocket to get to the moon? Well, that's division. So we're going to divide the total distance by the speed of the rocket. It's kind of like what you do if you need to figure out, well, how long is it going to take me to drive to Disneyland? Well, you know, we live 500 miles away from Disneyland. I could drive about 70 miles an hour. I do 500 divided by 7. So we're going to take the distance, divide by our speed. All right, so that becomes 5.4 times 10 to the 5th divided by 9 times 10 to the 4th. All right. Well, the cool thing is these 4 tens cancel out with 4 of the 5 tens, leaving us with 1 10 in the numerator. And so we end up with 5.4 divided by 9, that's this piece, times 10 to the 1st power. So if you wanted to, you could say, wait a second. 5.4 times 10 to the 1st power, we know what that is. That's 54. Because really all we're doing, this 1 says make your number bigger by 1 place value. So that becomes 54 divided by 9. 54 divided by 9 is 6. So the answer is that rocket, in order to hit the moon, will take 6 hours to get to the moon. Lots of words here. The GDP is the total national output of goods and services for a country. The GDP of a country was this number right here. And first, our job is to write that number in scientific notation. And the whole point of that is because your calculator doesn't fit this number in its calculator. So that's why you have to write it in scientific notation and do some of the work without a calculator, which actually is not so hard. So our number is 4926 followed by 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. All right. And now they want us to write that number in scientific notation. Now keep in mind, scientific notation means you're going to have that decimal after the very first digit. And then we know it's going to be times 10 to the something. Because we need to take this number and make it a big, kind of working backwards here. We're going to take this number and we need to make it into a big number. That means our exponent here is going to be positive. Now, exactly how big? How many place values? Well, if the decimal started here, it would need to move, let's see, if the decimal started here, it would need to move over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So our exponent is to the 11th power. So this right here is our scientific notation. So that's going to be 4.926 times 10 to the 11th power. And let's see, that's going to be, how do I move it? I want to move it. Oh, I can move it that way. So there is our scientific notation right there for this number. Okay, now, don't forget, you have to use the math palette. So anyway, if this is how much money the country makes, and this is how many people you have, if we want to know how much money is that per person, that means you're going to divide. So that means we're going to do 4.926 times 10 to the 11th divided by 4.5 times 10 to the 7th, because that's how many people we have. So we're going to divide. So what is our division going to look like? Well, it's not going to be too hard. It's going to be 4.926 over 4.5. And then what's going to happen here? These 7 tens are going to cancel out with 7 of the 11, leaving us with 4 tens. So this is going to be 4.926 times 10 to the 4th power over 4.5. And then, so now we are able to use our calculator. Well, actually, we don't need a calculator quite yet, because really, let's simplify this numerator. This numerator, this timesing by 4, let's get rid of it, and let's put it in standard notations, just a normal number. Timesing by 10 to the 4th power makes this number bigger, so our decimal is going to move to the right 4 spaces. And I have to add a 0 to make it go over 4 spaces over 4.5. So now I just have to use a calculator. Now I'm able to use a calculator because these numbers are small enough that I can fit it on my calculator. And so this becomes 49260 divided by 4.5. And I get this big old huge answer of 10,946.666666666. So it keeps going. But the question is, we're supposed to round to the nearest dollar. Round to the nearest dollar. So that means, here's your dollars. This 6 tells you to round up. So we know our answer is $10,947. And that's what you're going to put in your answer. You don't need to put the dollar sign, though, because they've already given you the dollar sign. So just put in your actual number. All right, so a family refers to a group of 2 or more people. In 2000, country A had, the average family had this much money. Holy moly. And there were about this many families. What's your total worth? So if each family has this much money and there's this many families, what are you going to do? Well, you're going to multiply. So we're going to multiply $340,000 times this many families. But that's not going to fit on your calculator. So what we have to do is do it all in scientific notation. So the first thing I'm going to do is I'm going to take this number right here, and I'm going to change it into scientific notation, which means it's going to be 3.4 times 10 to some power. So what's my power going to be? Well, it's going to be a positive power because I need to make it a big number. And it's going to start between the 3 and the 4 because that's the definition of scientific notation. You always start there. And it's going to get bigger by 1, 2, 3, 4, 5 place values. So since we know our number is going to get bigger by 5 place values, that means I'm going to put a 5 right here. So that's my exponent. So 340,000 becomes 3.4 times 10 to the 5th power. And then we're going to multiply it by 6.4 times 10 to the 7th power. So that becomes, we're going to do 3.4 times 6.4. We can use that with a calculator. Oops, I don't want the equal sign. What I want is, and then the 10 to the 5th, 10 to the 7th, that equals 10 to the 12th. Because you got 5 tens being multiplied by 7 tens, so that's 12 tens being multiplied. So it's 10 to the 12th. So now we're going to bust out our little calculator. And we're going to do 3.4 times 6.4. And we end up with 21.76 times 10 to the 12th. Technically, we're done. But that's not scientific notation. Scientific notation means you have to have only one decimal place. So really, we need to change this to 2.176 times 10 to the 1st. So this number right here becomes this number times by 10 to the 12th. So what do we end up with? That ends up being 2.176 times 10 to the 13th power. And that is how much money that country is worth. Holy moly. That's a lot of money. And that is what you're going to put in your box up there. Remember, you got to use your X, the multiplication symbol, in your palette.